Okay, you should have the paper like this, right? And then you could find out the point symmetry and also like the line symmetry. Okay, first the point symmetry. Can you guys tell me what do you guys get for the point symmetry?
Have H,
H, good. And then
I,
I,
N,
and then N,
O,
I, N, and then O,
S,
S,
X,
X, and also the Z, right? The point symmetry, right? So you could have the point in here and then draw the line to see if the point is going to be the midpoint of the line set, right? So this is going to be your point symmetry. And then the line symmetry, it should be easier for this one. Check your work. This one, check it out. Okay,
I don't think B is line symmetry.
good.
No, I don't think B is line symmetry.
I can't hear you, Jeffrey.
Well, I don't think B is part of line symmetry.
We should be the line symmetry. I could cut it half like this, right?
Oh, B,
B, depends on how you graph your P, right? So if I have the, like this one is obvious not, but from my picture, like here, like these two parts, if you have the same picture, it can be like the horizontal symmetry, horizontal line symmetry. It depends on how you write the P, right? Okay. Okay, next one. So transformation. In the following material, we will generate new figures from old figures by association of points. So we talk about the point symmetry, the line symmetry. Now we're gonna talk about the transformation. Usually when we talk about the transformation, we could imagine like we have the book here like this way, and then it was like here, right? And then you're gonna move around, okay? This is called like the transformation. Or we do have a three types of transformation. The first one, the slide or the translation, the refraction. Refraction is just like this, the mirror, okay, like this way, mirror. And then the rotation. Rotation, it can be a pen, and then I rotate like this way. Or I have the eraser like this, and then I rotate like 45 degrees. Okay, this is called the rotation. Refraction is like a mirror. And then the slide, it can be like from here, you move something like that. Okay, so this is three types of the transformation. Okay, the first one, the slides. Like here, I have the triangle ABC. When I use the triangle, I translate to the second triangle. I move it from here to here. So I create another triangle called DEF. Okay, we call this is the slide, or this is going to be the rotation, like this way. Okay, and then you're going to find it out. CF is going to be parallel to BE, parallel to AD. Okay, because they're going at the same width, so it's going to be parallel. And also, triangle ABC is congruent to that triangle DEF. Okay, they do have the same angle, and also they do have the same the same measure. Okay, so AC is congruent to DF, CB is congruent to FE. Okay, DE is congruent to AB, and also for each of the angle. Okay, so this is gonna be the transformation, the slide transformation. Yeah, the background is not necessary to this. It's not using like this word. Yeah. Okay, example 5. If we try to slide the X, Y, Z horizontally, Okay, I want you guys slide from here, the triangle. I don't have something. Okay, let's say this is the triangle, my triangle. I want you guys slide horizontally. Okay, just like this way, slide horizontally. So what would happen? Try to create a picture and form the triangle RST. Okay, RST. Draw the picture from here. Slide the triangle. Okay, you should have this one, right? And make sure you're gonna match the letter. They start with the X. So on here, this one is X. So this is gonna be the R from here. Okay, you have to match for each letter. Y will corresponding to the S. Z will be corresponding to the T. Did I do that? X, Y, Z. R, S, T. Like that. Okay, I don't know why. It should be the T, the S here and the T here. Hold on. X, Y, Z should be R, T, S. I make a mistake here. Change your notes here. Should be R, T, S. My bad. Okay, R, T, S. So X corresponding to the R, Y corresponding to the T, and Z corresponding to the S. Okay. This is called the slide rotation. And then again, these two triangles will be congruent. They do have the same angle and they do have the equal measure. Okay, make sure you change the questions here. It's RTS, not the RST. Okay, RTS here. Okay, then refractions. Another one called refractions is one type of the transformation. Just think about it. This is the triangle MNP. And then they do have the line in here. Okay, they have the line and then they have a triangle. And then they're gonna be reflexed. We think about it, it's just like kind of like the triangle is rotated around the line. Okay, or rotated around the line. So you could see the M and P reflects the triangle GHK. Okay, rotate the horizontal line in here. And we call this as the horizontal refraction. Okay, horizontal refractions going like this way. We could do the vertical rotation is going to be look like this. Okay, this is called horizontal rotation. And it can be the slant, it's kind of going like that way. Okay, or like this way. You rotate it like this way. Okay, example 6. I want you guys try to draw the refractions of the triangle ABC. Make sure you're gonna match the corresponding letter. Okay, we'll refresh the line by the L here. So draw the triangle here, X, Y, Z. Same idea for this one. Draw the triangle with the PQR. Okay, one more time. Make sure you're corresponding for each letter. Some more questions. Okay, check the work. So it should be like this way. Okay, and make sure this line, they have the equal measure. Okay, the L here should be the midpoint of these two lines. Same idea with this one. Got this? And then A is corresponding to the X, B will be corresponding to the Y, C will be corresponding to the Z. This one, you should have this. They rotate the line here, not the horizontal, not the vertical. Okay, you can see the line M is a little bit slant. Okay, this is a slant rotation. Oh, this is a refraction, not the rotation, sorry. The refraction. You could imagine like putting the mirror here. Okay, put the mirror on the line here, so you're gonna see the map image like that way. Okay, done. Okay, next one, the rotation. In this transformation, every point of a given figure leads to a point by rotation about a given point. So think about it. I have the way AB, okay, going like this way. The way AB is going to be rotated clockwise by the A here to an angle of 30 degrees. So you could think about it, the line like this, the way AB, and then rotate 30 degrees to get the AC here. Okay, get the image way AC. This is about like the rotation. And then same idea, you do have the corresponding point. A is going to be the A. B become the C here. And the center of the rotation, the A, this point, we didn't move at this point, right? So A will be called the center of the rotation. Okay, it doesn't move. Okay, next one. So in the figure below, square W, X, Y, Z has been rotated counterclockwise. Counterclockwise going like this way, right? Counterclockwise about its center. The intersection of the diagonals through an angle of 45 degrees. So in merger, you have the return this. Okay, this is the square, the W, X, Y, Z. And I want you guys rotate counterclockwise, like this way. And then how many degrees? Like 45 degrees. Okay, 45 degrees. 90 degrees is gonna be still a square, right? So 45 degrees is gonna be half like that. Okay, try. Just grab it like this. Rotate 45 degrees. And then you're gonna be drawing like this square. And then move the W, X, Y, Z counterclockwise and going like this. Okay, so you should have this the picture like that. 45 degrees. Okay, so this is called the H-point finger form is the regular octagon. Okay, the octagon, just like the star here. Okay. Okay, next one, next example. I want you guys try to rotate this work 180 degrees. Look like this way and then rotate the 180 degrees. What is gonna be equal to? Okay, one rotate 180 degrees. What do you guys see the word? What word is produced?
How?
How. Yep. It's almost how, right? The M is a little bit weird. Okay. This session is pretty straightforward, like the line symmetry and the wall and the point symmetry. Okay, I didn't put that much on the exam for this session. Okay, done. So we're done for the chapter 2. And did you guys print it out? The construction pancakes? Do you guys have that one? Chapter 1 and chapter 2. Hey, we're gonna do it together, okay? It will be easier if you have the paper and then you do have the tools. Remember I say, buy the complex, right? I just need the simple one, okay? The really, really simple. Mine is really, really simple. Okay, and I need that, the compress, the eraser, the ruler. Okay, I need these few things and this one. I need you guys get ready for the paper, this paper. Do you have that? You guys have that? Hey, this is part of your homework. We only have like, how many? 1, 2. We only have a free construction packet, and this is like 10% of the total grade. So basically, you have everything with you, and then we're gonna do it together in class. And you just turn it in, and then you get 10%. Okay, this is like really easy to get 10% for the total grade. Okay. But if you do it on your own, it will be really, really challenging. Okay, right? Ready, right? So let me set it up. Let me set it up my camera so you guys can see how I did that. Okay, so please get ready for your compress. Okay. You guys see my paper here?
Thank you, Mom. You made my day.
What happened?
No.
Huh?
No, it's because Sean. I love this song, but Sean hates it. Gets annoyed. Well, not hate it, but she gets annoyed when I play it around her.
Okay.
She's a butt.
Good, right? You guys have everything ready? Okay, maybe I'll show that here. Okay. You guys see my paper? Guys?
I
Good.
can see the picture. Okay, yeah.
Okay, right? And let me know if I brought like the camera or something, okay? I try to set up like this way so you guys can see what I'm doing here. So the first one, I need you guys have the compass, okay? Just like this one. Okay, mine is really simple. I just put the pencil here and that's a pointer here. Okay, you can see the pointer and the pencil. The pointer, you want to hold the point so you guys can draw, right? So with the compass, you guys can construct a circle. Okay, like put the pointer on the center O and then use the pencil to draw the arc. This one we call the arc, okay, the arc AB. So first one, we need to do construct a segment congruent to a given segment. So the given segment AB, you guys see the AB here? So I want you guys construct the segment exactly the same length with the AB. So we call this is going to be the CD here. Okay, I want you guys with this line, use the compass, construct the line CD. And CD will be congruent to the AB. Okay, like some students ask me, hey, how come why don't you just use the ruler to measure it? We want to try it like, looks like more professional. Okay, we want to try to do something, it looks really hard, okay? So we need to use the compass. Okay, I'm gonna show you guys the steps, so you just follow me what we need to do. First one, put your pointer to the A here. Okay, just like mine. Okay, and then use the pencil, draw the arc on the point B. So you could see like that. When I draw it, you're gonna hit like that way, right? Okay, I forgot. The first one we need to do, we need to draw the line first. My bad. Okay, draw the straight line here. And then whenever here, just put the point C. Okay, draw the straight line and then get the point C here. Okay, and then one more time, use the pointer, hold it on the point A, and then use the pencil to hit the point B here. And then we're gonna draw the arc here, okay? Okay, we're gonna keep this radius for the compass. Don't move it, and then move it to the point C. Do the same thing, drawing the arc. And this point here, we're gonna say this is gonna be the D. So we know that the CD, the segment CD will be congruent to segment AB. Okay? Anyone questions? Hey, I can't see you guys the face right now because I only have a one screen, okay? So let me know if you want me to do it again or you get stuck or something. Good. Okay, right? Okay, now if you guys good, I'm gonna do the second one. This is like just the warm up, okay? This is the easiest one. Okay, second one. To construct the midpoint M of a given line segment AB. So we have the segment AB here. And then we're gonna construct the midpoint M here. So AM equal to MB. Okay, ready, right? So now I use my compress, point it to the A, okay, do it to the point A. And you want to open the compress to a length greater than 1/2 of the AB. Okay, not half of them, okay, a little bit greater than 1/2. And then draw the big arc here. Okay, draw the big arc here. After that, we're gonna use the same radius. Okay, don't move everything. And then now this time I'm gonna point it to the B, point B. I move it already. Okay, let me do it one more time. You can't move the compress, okay, get the same radius. Okay, like this one, don't move. And then go to the point B and then do the big arc again. Okay, the big arc has to be the intersection with the A. So you're gonna see like this. Okay, and then now we just name the intersection point. I'm gonna call C here and then the D here. Okay, we are not done yet. Are you guys following me with here? Good.
Yes.
Okay, thank you. Okay, so next step, we want to draw the midpoint M, right? Now we're gonna draw pass through these 2 points. Draw the line with the CD, the segment CD, and then the CD will be called the segment AB here. And then we do have the point here. We're gonna see the M. This is gonna be the midpoint. So you know AM here will be congruent to M, the MB.
Oh,
Hey, when I grade the construction paper, I need you guys to show me all those are, okay? If you only give me like the AB here, like A, B, and then you just like use the ruler to get the midpoint M, okay, this has got 0. This is a 0 points. I need to see like the evidence you guys using the compress. I will see like those are here, like here, okay, to get the midpoint M here. Okay, so this is the session 1.2, session 1.2 for the construction 1, construction 2. So you have this picture. Good?
Professor, I have a question.
Yes.
Mine looks a little different than yours. Is that okay?
I need to see. Hold on.
Oh, I can show you later.
Yeah, show me later. Okay.
Got
it. Yeah. Okay, if it doesn't work, try to do it one more time. Just point it to the A, open a little bit greater than the 1/2 of the B, and then get the R, use the same radius, point it to the B, and got them like that way. So you're gonna hit the 2 intersection point. That will be the C and D. Draw the line here. That point will be the M. It should be AM equal to MB. Okay. Then 1.4. Okay, 1.4. This one. Okay, let's see. To construct an angle congruent to a given angle. So we have the angle here, RST, right? I want you guys construct another angle called NPQ, okay, NPQ. And NPQ should be congruent to RST. Okay, so we have this one, we want to draw exactly the same thing here. Okay, the angle is gonna be congruent. So look at my step. First, I want you guys draw the PQ. Okay, the point PQ, it doesn't matter, okay? You don't have to copy the ST here. Just whatever, get the line. The endpoint here will be the P, and whenever here, that will be my Q here. Okay, and this is the way PQ. Okay, good, right? Now, second step, use your compass. Point it to the S. Okay. Point it to the S here. And then make it like a little bit smaller than the alt here. Okay, point it to the S. And then just draw the arc, whatever here. The arc is gonna be intersect the SR and the ST. And this one, we call that would be the GH. Okay, the G here, and then the H here. Okay, after you draw it, just don't make sure you don't change the radius. Okay, keep this radius. After you draw the GH, wait, let me do it one more time. Okay, the arc GH, don't change to keep the radius here. And then we're gonna use the same radius to mark an arc to intersect the PQ. Use the same radius to mark the arc to intersect the PQ. Okay, one more time. Use the S, point to the S, get an arc with the GH. Keep the same radius, and then go to the P, mark an arc to intersect the PQ here. Okay, right? Now, I'm gonna use the point G, okay? First the point G, and try to intersect the H here. Okay, arrange your radius, make sure you intersect the H with the arc here. Use the same radius at the point G here, and then mark the arc here also. Okay, so this point will be the G. One more time, okay, I'll do it one more time. This is not the G, sorry. This is gonna be the K. Let's skip one step here. K here. Okay, I'll do it one more time, guys. Point it to the G, and then get the R intercept for the H. Use the same radius at the point K here, and get the R in here. Now, I'm gonna draw the line from the point P to this intersection. Okay, use the P and the intersection point here. Draw the line. And this is the way I call this is gonna be N at this point. So I will have an N, P, Q. It's congruent to the angle RST. Okay, angle NPQ congruent to angle RST. Are you guys okay? Then they will have the same angle in here. Okay, right? If you guys didn't stop me, I'm gonna keep going, okay? So this is a construction 3, and then we have the construction 4 here. So the fourth one, to construct the angle bisector of a given angle. So angle bisector means I want to draw the line and divide up this angle into two, right? So that will be the RS, the line is going to be called RS. The way RS will be cutting the PRS congruent to the SRT here. Okay, so starting from the R here, we use the R to the point and just open a little bit smaller than the PT. And then we're gonna draw the R to intersect the P and T here. Okay, and this one, I will call, this is gonna be my M and N. Okay. Okay, second step, I'm gonna point it to my M. It's approximately like a line like here. I'm gonna draw the arc here. Okay, and then I'm gonna use the same radius. Go to the end. Use the same radius, go to the end, and then draw the same arc here, like this way. Okay, one more time. Use the M, approximate in the middle here. We're gonna draw the arc, and then use the same radius. Go to the end, and then draw this arc also. Okay, so you're gonna see this intersection point, and then you want to connect it together. Like this. And this is the way we call this is gonna be the S. Okay, point S. So we have PRS congruent to SRT. Okay, angle PRS congruent to angle SRT. Okay, so that will be the RS will be the angle bisector. Okay, hey, one more time. When I create the construction pancake, I need to see this. Okay, I need to see this arc, the line here. Okay, don't erase it. Okay, this is the way you told me you guys use the complex.
Does anyone have a phone charger?
I'm sorry.
It's in my backpack.
Sean Adams, you're not muted.
Okay, right? Okay, another one. Session 1.6. Okay, 1.6. To construct the line perpendicular to a given line at a specific point on the line. So AB, the line AB with the point X. And I want you guys construct a line EX. So I want you guys to get a vertical line here. And EX will be perpendicular to AB. Okay, EX will be perpendicular to AB. So first step, we're gonna using X as a center. Mark off arcs of equal radius of each side of X to intersect A, B, and C. Okay, so like here, point it to the X, and then make it a little bit smaller. Okay, get the arc here. And then use the same radius. Do the same thing here. Okay. I have difficulty for this one. Okay, one more time. Point it to the X. And then get the arc. Use the same radius. Something what? Hold on. Let me do it one more time. Use the same radius to get here. Okay, and then I have this C and D. So this is gonna be my C. This is gonna be my D here. Okay, and then now we're gonna using the C and D as a center. Okay, use the C and D as a center. And it's gonna be mark and arc here. Use the same radius at the D to mark an arc here. Okay, now I'm gonna draw this intersection point with the X. I don't have the good picture here. Like this. And then this point, we call this is gonna be the E. Okay, and then we say E, the line EX is perpendicular to the line AB. Okay, when they say perpendicular, means this is gonna be the right angle, the 90 degree. Are you guys good?
Is
Okay. Okay, right? Now, session 2.1, the last one. Okay, the last one here. Construct a line that is perpendicular to a given line from a point not on the given line. So that we want to construct the line PQ perpendicular to R. So we want to draw the straight line here perpendicular to R. Okay, step one. We're gonna use the P as the center. And then draw the line here to intersect. That's too small. Draw the arc here and intercept the line L. And these two lines, we're gonna call A and B. These 2 points. These 2 points, that will be your point A and the point B. Okay. Now,
You're speaking to?
yes. Okay, one more time. Use the point P as
I
the
don't.
radius. And then draw the arc, intersect the A and B.
So I was redirected to a counselor. Someone told me to speak to someone on
Hey, Sean.
finding out if I could get my verification.
I'm sorry? Hello?
It's a official verification of intent to earn an associate degree for transfer.
No, it says
I
someone on
need
the
this
phone.
for to admit myself to CSU will be.
Hello? Hey, don't talk. Don't make a phone call during the task, guys. Okay, so after you have the, where am I? Okay, after we have the arc AB, we're gonna use the A has a center. Okay, the center A. And then approximately draw the arc here. Okay, and use the same radius going to the point B and draw the arc here also. Okay, let me put it. Okay, and then we're gonna draw this point P and the intersection here. I don't have the good picture. Let me do it again. One more time. Okay, so this is gonna be point B. This is gonna be point A. Then use the same radius. Another arc. Okay, connect this part here. And we call, that will be the Q. And then we know PQ, line PQ is perpendicular to the line L. PQ perpendicular to L, so this is gonna be a right angle. So you could conclude that we could call this point to be the R, angle ART, congruent to angle BRP. ARB congruent to angle BRP and is equal to a right angle. Okay. Question, guys?
No.
Let me get back on guys. Okay, can I see? Can I see? Can you show? Can you guys show it to me like this way? Just make sure. Let's have the paper with you. Just hold it to the camera. Good. Pretty good. Oh, really good. Okay, one more time. When I grade it, I need to see like those track mark here, the arc here. Okay, so we are done already. Just turn it in on the canvas. Okay, so go to the canvas. Click on log into the canvas. You're gonna see the construction chapter 1 and 2 here, right? Click on it. And then you could submit here. Okay, make sure combine a one PDF file, okay? Even though you could attach like 10 files here, I don't want you guys to do it. Make sure combine it only one file. Turn it in. The due date is gonna be March 13. Oh no, due on March 13. I don't know why I give you guys so much time on it. Yeah, but try to turn it in. Once you're done, just turn it in, okay? So again, we only have a free set of the package. It's gonna be 10% for total. So each part is gonna be 3%. Okay, this easy points, you guys can get it. Okay, 3% already. So turn it in before the due date. Okay, don't wait, you're gonna forget this homework. Okay, the construction chapter 1 and chapter 2. Okay, now I want you guys take a break. Come back at what time? 3:20. Okay, come back at 3:20. Okay, guys. Yeah, finally, I figured out my Zoom. Okay, session 3.1. Congruent triangles. Okay, congruent triangles. These sessions we talk about the triangle here. First one, congruent triangles. Two triangles are congruent if one constant with fits perfectly the other. In figure below, we say that triangle A, B, C congruent to the triangle D, E, F. If this congruent hold, okay, so look at the picture. Remember, like all those means like there's a one line here, there's a one line here. That means AB is congruent to DE. Okay, and then you use this the two lines here, this is the two lines here. So CB is congruent to FD. Same idea, the third one here. AC congruent to DF. Same with the angle. Okay, this is a angle A congruent to angle D. Angle C congruent to angle F. Angle B is congruent to angle D. Okay, so write it down on your notes. Okay, we do have a three angles as a congruence. And also, we do have a three segment. Okay, the segment, the line, the size here, they are congruent. So total, how many parts do we have?
Six.
How many parts are congruent?
6 parts. Wait.
6 parts, right? We have a three angles and three sides. So total would be like 6 parts. Okay, this is a congruent angles. Corresponding angle are congruent. This is corresponding sides are congruent. So 6 parts. They write it down on the notes. The notes is missing these 2 parts here. Okay. So definition, 2 triangles are congruent. If the 6 parts of the first triangle are congruent to the 6 corresponding parts of the second triangle. So this is the definition, and this is actually it's gonna be if and only if. If you could prove that these 6 parts are congruent to the second triangle, it means these 2 triangles are congruent. Or if I say these 2 triangles are congruent, that means the 6 parts of the first triangle will be congruent to the second part of the, will be the corresponding part of the second triangle. So this is a if and only if, okay? 3 angles and 3 sides. And then from the indicate congruence, we also say that the vertex A corresponds to the vertex D. And the B, the vertex B is corresponds to the vertex D. Vertex C is going to be correspond to the vertex F. Okay, so we could write it like this way: A with the correspond to the D, B correspond to the E, C correspond to the F. So when you say, when you land the triangle A, B, C, you have to do it in like this order. Okay, triangle A, B, C congruent to triangle D, E, F. Okay, you have to match. Go back here. You have to match for each vertex. A correspond to the D, B correspond to the E, C correspond to the F. Okay, you guys can't mess up the order. Okay, so pay attention at this part. Triangle ABC is congruent to DEF. So actually, if I show you guys without the picture, if I don't show you guys the picture, I only ask you guys say, hey, triangle ABC congruent to triangle DEF. you could tell which vertex is going to be corresponding. Okay, this one. Think about this one. I don't have the picture, it's in here, okay? We have the triangle MNQ congruent to triangle RST. Can you guys write it just like the previous example? Okay, which vertex is corresponding? Okay, I don't have the picture here, okay? I want you guys to do it on your own. Which vertex is going to be corresponding? Okay, so check your work. You should have an M corresponding to R, right? And then N corresponding to S, Q corresponding to the T. Okay. So when I draw another triangle here, that will be R, S, T. Okay, so that's why I could conclude that angle M is congruent to angle R. So I do have the same angle here. This one, angle M will be congruent to angle R. And angle N is going to be corresponding to the angle S, is congruent. And also angle Q, that will be corresponding to the angle T. Okay, right? So even though I don't have the picture, I don't have like this information, by looking the clamp here, triangle MNQ congruent to triangle RST, I should have all the information. And also I could tell the NQ, the NQ will be congruent to ST. MN congruent to RS. And then last one, MQ will be congruent to RT. Okay, right? So be careful when you guys writing two triangles are congruent. Make sure you guys match with the corresponding parts here. Okay. So we ordered this vertex to make the clamp MNQ congruent to RST. Hey, missing here. What's it done here? We could write MNQ corresponding to RST, or we could do NQM corresponding to STR. Okay, write it down on your notes, okay? Your notes is missing here. The clamp here. Okay, write it down here. If you're done, try to do the example one. Okay, example one, try. This time they given the correspondence of the vertex. And now I want you guys write it down the triangle BCA is congruent to what?
EFD.
Good. You could match in here, right? B corresponding to E. So E, F, D. Good. Second one.
Triangle ABC.
Good. ABC. Okay. Okay. Then two triangles are congruent if the sixth part of the first triangle are congruent to the sixth corresponding part of the second triangle. So we say this is a if and only if statement. Okay. So they say the definition is reversible. So you could be given the sixth part of the first triangle congruent to the six corresponding parts of the second triangle. Then you know these two triangles are congruent, or another way around. Okay, this is a if and only if statement. Okay, so now look at these two triangles. I have the angle M and Q congruent to the angle, the triangle RST. So you could tell these two triangles, they have the refraction. Okay, they have refraction, just like the section 2.6. It can be like the refraction. I don't have something like that. Okay, so just like this eraser here, so it can be refraction like this way. Okay, so another way like this. Okay. Okay. And then for the congruent triangles, we also can use the relations. Remember what is the relations? Yes, no? What is the first relation?
N is congruent to S.
Oh. Remember that A, R, A. You guys remember that? Number two, what is it? A, R, B, and then? Wait, guys. B, R, A, remember that? No? Refractive. This is a symmetric. And what is the number three?
Transitive.
How can I represent it with like this way? A, R, B, and then?
BRC.
Good. B, R, C, and then?
ARC.
Good. A, R, C. Remember that? That is from chapter 1, right? I guess. Reflexive, symmetric, transitive. This is called the relation, right? We also can apply it to the congruent triangle. Okay, we could use that on the congruent triangle. Okay, look at here. First one, I could say congruent triangle ABC congruent to triangle ABC. This is reflexive property. Okay, write it down on the notes. The notes is gonna be here. 1, 2, 3. There's a missing on your notes. So triangle ABC congruent to triangle ABC. This is talking about the ARA here. Reflexive property. So what do you guys think about the number 2? If the triangle ABC is congruent to triangle DEF, and then symmetric.
Triangle DEF congruent to triangle ABC.
Good. If triangle ABC congruent to DEF, then DEF is congruent to ABC, just like this way, right? AB, ARB, and then BRA. ARB, BRA. Symmetric property. So you guys can guess the number 3, right? Hey, write it down first. Give you guys some time to work on it. So number 3 will be ABC congruent to DEF, DEF congruent to GHI, then ABC will be congruent to GHI. Okay, so that will be the number 3, ARB, BRC, and then ARC. Okay. Okay. So we keep saying that like the two triangles are congruent. Okay. So now we want to know how can we prove these two triangles are congruent. We have a couple methods to prove the two triangles are congruent. The first one, that's called SSS method. Hey, guess what is the meaning of SSS?
Side.
Good. Side. Okay, SSS means side. Okay, the first method to prove the triangles are congruent, we want to prove the sides, they are congruent. Each side is going to be congruent to each other. Just like this picture. If I can show MN is congruent to RS, MQ is congruent to RT, and NQ congruent to ST. This is called side. So if we could show these 3 sides are congruent, then we could say triangle NMQ congruent to triangle SRT. And the reason is SSS. Okay, this is the first method. And this is also the postulate 12. If the 3 sides of the one triangle are congruent to the 3 sides of the second triangle, then the triangles are congruent. Okay, so we're gonna use the reason of SSS. Okay, right? The first one, this one is really easy. Side. Okay, example, given the segment AB and the segment CD each other at M, okay, the intercept at M here. Given AC is congruent to DB. You can see the line here, right? This means they are equal, they are congruent, equal measure. Okay, AC is congruent to DB. So now I want you guys prove triangle AMC congruent to triangle BMD. Okay. So right now I only teach you guys the first method, right? The side. Can you guys try? If you, one more time, you want to prove these two triangles are congruent. So you want to prove the first three sides of the triangle is congruent to the corresponding of the three sides of the second triangle. If you can prove that, then you could tell these two triangles are congruent. The reason is side, 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 the SSS. Try to do it by yourself. Okay, let's see. The first one, we're gonna write down the given information, right? So here we're gonna know AC is concurrent to DB. We already have the first side. So now I need to prove these two sides are congruent. Then I know these two triangles are congruent, right? I already have the AC equal to DB. So second one, I'm gonna say AM concurrent to BM. Why?
A bisected line segment is split into two equal parts.
Good, really good. If a segment is bisect, I know M is bisect for the segment AB, right? So the segment form a congruent. So you know AM congruent to MB. Hey, after I put on this one, I put this notation on the picture. So I already know these two sides are congruent. Okay, so now I need the last one. CM will be congruent to MB. Same reason, right? Because M is bisect on the CD also. Okay, so I'm gonna put same reason as number 2. And then again, I put the check mark here. So I'm gonna remember CM congruent to MB or DN. They try to get like those track mark like for the angle or the side is congruent. Okay, so you could remind yourself what is the reason to prove these two triangles are congruent. Okay, right now I only teach you guys the side, right? So now at the end, for number 4, I could say that triangle AMC congruent to triangle BMB. Again, be careful when you guys writing like this one. Make sure all those vertices are corresponding. Okay, A is corresponding to the B, M is corresponding to the M, C is corresponding to the B. What is the reason? No? What is the reason?
Corresponding. Recipients are congruent.
A. Your notes. I just say, go back. Here, yeah. This is the method for proving triangle, right? If you guys can prove 3 sides are congruent, then these 2 triangles are also congruent. And then you guys just prove if these 3 sides are congruent, right? So this 2 triangle has to be congruent. The reason is SSS. Just put side. Hey, that's a typo. This is a 4, not 5. Okay, this session is pretty straightforward, okay? Just look at the picture. The first one, if you want to prove the triangle is congruent, prove all those sides are congruent. The reason is side. Okay. Okay, right? Now, I'm gonna talk more about it. For this picture, the step 2 and 3, the 3 pairs of sides were chosen to be congruent. SSS is the side has the reason that justify y angle AMC congruent to BMB. And actually, if I want to see congruent, means like they are exactly the same triangle, okay? Regarding to the side and regarding to the angles. Okay, but when you look at the picture, it doesn't look like they're exactly the same thing, right? Because this triangle, if you try to rotate it clockwise or counterclockwise, like if you want to move the AMC clockwise to 180 degrees, so you could see they're exactly the same triangle. Okay, now second method, SAS. Guess what is the SAS?
Angle side.
Side, angle, side. Okay, and make sure the angle is gonna be in between 2 sides here. Okay, it has to be consecutive. Okay, like want you guys keep in mind that SAS, this is not equal to SSA. Okay, when they put like side or SAS, this is in order. Okay, talking about the side, angle, side. Okay, the angle has to be in between here. So the order doesn't matter. Okay, so this one is side, angle, side. Okay, the angle has to be in between two sides here. Okay, for example, if the two people draw a triangle and the side is going to be 2 centimeters and 3 centimeters, and the include angle measure 54 degrees. Okay, so they can be, these two triangles are congruent. And this is like the refractive, right? The refractive, the transformation, the refractive triangle. Okay, and one more time. Side, angle, side. The angle has to be in between these two sides. Okay, angle has to be in between these two sides. If I have two angles like that, for example, if I say this is 2, this is a 3, like that. And then for example, the angle like here is gonna be 40 degrees. You can't use the SAS, okay? You can't use the side angle side because the angle is not in between these two sides here, okay? So keep in mind, it has to be in order. Angle is gonna be in between two sides. So side, angle, side. Postulate 13. If two sides and the include angle of one triangle are congruent to two sides and the include angle of the second triangle, then the triangles are congruent. Again, this is the if and only if. Okay, if and only if. So the second method to prove the triangles are congruent, that would be side, angle, side. Okay, we're gonna learn the second method. The first one is side, side, side. Second one, side, angle, side. Okay, try. I want you guys try to do it by yourself. This one, try to use either side, side, side or side, angle, side. Okay. Hey, this one you guys gonna use the SSS or SAS?
SAS.
SAS.
SAS, okay? So it has to be sine, angle, sine, right? Okay, so first one, they're gonna tell MN concurrent to NQ, MN concurrent to NQ. So this is gonna be the first one, first sine, right? First sine, MN concurrent to NQ. And then, how about angle 1 and angle 2?
Congruent.
Congruent. Why?
Two lines are perpendicular. They create two 90-degree angles.
Good. Two lines are perpendicular. They meet to form concurrent adjacent angle. Good. So I have a S, A already. I need one more side. Which one? You want to use SAS, right? The sine, angle, sine. So I do have the sine, the MN equal to NQ. And I do have the angle, angle 1 concurrent to angle 2. What is another side?
NP.
MP. Good. Are they equal to each other?
Yes.
Yes, because they are exactly the same line here. So I'm gonna say PN is concurrent to PN. The reason it can be identity or reflective. Remember the ARA? Either way, you could use identity or reflexive. Because it is an identical line here, right? So you have a S, AS. And then now you're gonna conclude triangle PNM concurrent to triangle PNQ. What is the reason?
SAS.
Good, SAS. Okay, so far we have sine, 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 angle, sine. We have a more. Number 1, sine, sine, sine. Second, sine, angle, sine. Okay, what is the number 3? It's gonna be ASA. What does ASA means?
Angle, side, angle.
Angle, sine, angle. And again, this time, the sine has to be in between, okay? The sine has to be in between two angles. Okay, ASA. Okay, ASA. So like for example, I have an angle A, the sine 5, and then the angle 47, and ASA. ASA. So these two triangles are congruent. Okay, and make sure for these sessions, you guys can't skip the sine or the angle. Okay, you can't do like angle, sine, and using this angle. You can't do that. It has to be consecutive. Okay, angle, sine, angle. Okay, or sine, 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 like that way. Okay, so another postulate two angles and the include size of one triangle congruent to two angles and the include size of a second triangle. Then the triangles are congruent. Okay, again, if and only if. Try this one. Using the ASA. Angle, sine, angle. Okay. So see the first one, I'm gonna put the given information, right? Excuse me. So C is the midpoint of this segment BD. So if C is the midpoint, then BC that will be equal to CD, right? This is gonna be the first side. BC congruent to CD. The reason will be the midpoint segment forms two congruent segments. So I have the first line here. Okay, and then which angle you're gonna use? We want to use ASA, right? We do have the side already. We do have a BC congruent to CD. So can we use these two angles? Are they congruent?
Yes,
Why?
they're vertical angles.
Good. BCA congruent to ECD, right? BCA congruent to ECD. Because reason is vertical angles form congruent angles. Okay, vertical angles are congruent. And then
Angle ABC is congruent to angle EDC.
good. ABC congruent to angle EDC. Okay, because these two angles are right angle. Right, right angles are congruent. I did write one more things in here because they didn't tell these two angles are 90 degrees, right? They say just say AB perpendicular to BD and BD perpendicular to DE. So you can't just say ABC congruent to EDC. You have to explain it. How do you know? Because using the given information here, perpendicular lines formed a right angles. Okay, my picture shouldn't have like these two square here, actually. Okay, because they only say perpendicular. It doesn't mean this is gonna be right triangle. Unless you write it down here, explain it, then you could put these two square here. So you have an angle, sine, angle. So you could say angle ABC is congruent to angle EBC. What is the reason?
ASA.
ASA. Good. Okay, we are not done yet. Okay, we only introduced like 3 methods to prove triangles are congruent. Okay, we still have 2 more. Okay, we have 2 more. And then I'm gonna stop here. I don't want you guys start with the next one. Okay, and that's another one. Okay, the AAS. We're gonna talk about it on Thursday. And again, on Thursday, we're gonna cover the session. We're gonna finish the session 3.1, and we try work on the session 3.2 a little bit, and then I will let you guys ask me the question about the test 1. We will have the test 1 on Tuesday, okay, in class. So I give you guys the practice test. You will find the practice test in Canvas. Okay, try, print it out, do it by yourself. That's a 6 pages. Okay, try your best. I will post the solution like by the end of this weekend, but I want you guys try it before you look at the solutions. And then if you guys have any questions, you can ask me on Thursday. Hey, one more time, we won't be able to cover all the questions on Thursday. Okay, we only have about an hour to cover the practice test. So I want you guys try to do it by yourself, okay? And then if you have any questions, ask me on Thursday. And make sure show all your work on the exam and use the reason to support your equation, okay? And also try to finish your homework. The session 2.2 to 2.6 is going to be due on this Sunday. Okay. And again, one more time, remind you guys, some of you, if you don't have the webcam, you don't have the camera, you need one for your exam. If you won't be able to buy one, you may ask your friends, like go to their place or ask someone to get you the webcam for the exam. Okay. I don't want you guys use the cell phone to take the test. From my experience, if you're using the iPhone, they always, I don't know why it's going to get disturbed, you're going to be kicked out on the exam, and then you won't be able to log in back. Okay, so it's better you guys use the computer. You could try on it. You could try to use your device, like, I don't know, like iPad, computer, iPhone. Try it to see if it works on the practice test here. And one more time, if you didn't watch the video, please do it as soon as possible. That will be in the announcement. Teach you guys how to use the Google Chrome to take the tutorial exam. Okay, let me know if you have any questions on Thursday.